The first step is converting the sec 2x to a cos 2x. So once I have converted, then this can be written as x. So you know that tan square theta is 1 minus cos 2 theta by 1 plus cos 2 theta. So therefore, you can write
Yes,
this
sir.
as x tan square x dx. Okay. In the next step, what you do is you, since it is very difficult to integrate tan square x or differentiate even tan square x, but you can convert tan square to a sec square. So what you do is you write tan square as sec square x minus 1. You convert tan square to sec square. Okay. Now, what you do in the next step is you multiply everything. Okay.
Okay, sir.
And now you separate. Okay. Now the first one, x sec square x, we have already discussed this kind of this integral. Okay. The first integral can be done by parts. Okay. We have already discussed it actually. Still, uh, take x as your first function. Uh, in fact, take x as your second function. You can take x as your first function also. X as your first function, integral sec square x dx. Because from Eilert rule, x is an algebraic function, t is a trigonometric function. That's why I've taken x as my first function. Minus integral of the derivative of x into the integral of sec square x dx. And whole thing dx, and let us not forget the minus integral x dx that is there. Or you can write x in, you can write this integral x dx as half of x square. Okay. And this becomes integral sec square x is tan square x. So this becomes x tan x minus integral ddx of x is 1. Integral sec square x is tan x. So this becomes simply integral tan x dx minus half x square. So this becomes x tan x. And you know the integral of tan x, it is standard integral. Integral of tan x is log sec x minus half of x square, and you add a constant of integration. So that is what you can do this way. Okay. Any question?
No, sir.
Let us now come back to recurring integrals. Now, recurring integrals is very important, especially this integral that I have done with you. Please go through this example very carefully, and please be very
Okay, sir.
careful while integrating, because I confused with 2x and 3x yesterday. Okay, this integral is
Okay,
Okay.
sir.
very important. Okay, please go through this integral. And one more,
Okay,
this
sir.
type of integral I'll take today. Okay, but this time in a little different form. Okay, and this integral is integral e to the power of 2x cos square x dx. How to integrate this? Now see, this does not look in the form e to the power of in the previous form, right? This is a product of a trigonometric function
Yes, sir.
and an
Yes, sir.
exponential function. But the problem here is that we have a power of cos, which is a square. And in the previous integral that we have done, we did not have any power here. But did we have any power of sine 3x? No, we did not have. Okay,
No, sir.
so that is why from cos square x, you need to convert this, the square power, you need to remove. Okay, and how do you remove this power? With the help of your multiple angle formula. What you do
Okay.
is you write this as half integral e to the power of 2x 2 cos square x dx. And you know that what is 2 cos square theta? 2 cos square theta is 1 plus cos 2 theta, right?
Yes,
Yes,
sir.
sir.
Now we can do this very easily. Distribute the integral, or in fact first multiply. You get e to the power of 2x plus e to the power of 2x cos 2x, whole thing dx. Okay, now this is half. Now you can distribute the integral. You have e to the power of 2x dx plus integral e to the power of 2x cos 2x dx. Okay, next half. What is integral e to the power of 2x? It is e to the power of 2x by 2, right? Plus. Now this one again, you integrate just like the previous one. Okay, you take e to the power of 2x as your first function. Now, but instead of evaluating here, let us call it I1. Okay, we'll see what we can, how we can integrate I1. We'll integrate I1 separately. So where
Okay, sir.
I1 is equal to integral e to the power of 2x cos 2x dx. So again, take e to the power of 2x as the first function, e to the power of 2x integral cos 2x dx minus integral derivative of e to the power of 2x into the integral of cos 2x dx, and whole thing integrated with respect to x. So this is integral cos 2x is, what is the integral of cos 2x? It is sin 2x by 2.
Sine
So
2x.
this is e to the power of 2x sin 2x by 2. Okay, minus integral ddx of e to the power of 2x. ddx e to the power of 2x, you know, is 2 e to the power of 2x into integral cos 2x is again sin 2x by 2
Yes, sir.
dx. Okay, so what happens here? This 2 and this 2 cancels. So what effectively again you are getting is, you are getting e to the power of 2x sin 2x by 2 minus integral e to the power of 2x sin 2x dx. Okay, now again what we do is we again integrate by parts. So this is e to the power of 2x sin 2x by 2 minus integral e to the power of 2x integral sin 2x dx minus integral of the derivative of e to the power of 2x, okay, into the integral of sin 2x dx, and whole thing integrated with respect to x, and close your brackets.
Okay, sir.
And this is e to the power of 2x sin 2x by 2 minus integral, this is e to the power of what is the integral of sin 2x? It is minus cos 2x. So this becomes minus e to the power of 2x cos 2x by 2 minus integral derivative of 2 e to the power of 2x is 2 e to the power of 2x, and integral of cosine 2x is what? Cos 2x by 2 minus cos 2x by 2.
Cos 2x by 2. Minus cos 2x by 2.
So this minus and that minus combine to become a plus. So cos 2x by
Yes.
2 dx. So now what happens? This 2 and this 2 cancel off. So now if you open the um, this integral, why have I written here? This integral. No need to write. Okay. So now what happens here? Now if I open the brackets, e to the power of 2x sine 2x by 2 minus and minus become plus. When you open the brackets, it becomes e to the power of 2x cos 2x by 2. Okay. Minus, because I'm opening the bracket, this plus sign becomes a minus. Minus
Yes, sir.
integral e to the power of 2x cos 2x
2x cos x. Cos 2x. Yes, sir.
dx. Now what
dx.
happens? Now what do you see? What is this integral? This integral is what? This integral is the integral that we started with, right? I1.
Yes, sir.
Yes,
So
sir.
Yes,
this
sir.
integral is nothing but I1. So in the next step, we are going to write e to the power of 2x sine 2x by 2 plus e to the power of 2x cos 2x by 2 minus I1. Okay, so what are we getting? Thus, I1, we are getting I1 as e to the power of 2x sine 2x by 2 plus e to the power of 2x cos 2x by 2 minus I1, right? So therefore, now if you take this I1 on the other side, you get I1 plus I1 is equal to,
Yes, sir.
you can take e to the power of 2x common, e to the power of 2x common, if you take, you get cos
Yes, sir.
2x
Sin 2x plus cos
plus
2x
sin 2x divided by 2.
divided by 2.
So that means you get what? Twice I1
Yes, sir.
is equal to e to the power of 2x cos 2x plus sin 2x
Plus
by
sin
2.
2x. Yes.
Therefore, what is I1? I1 is e to the power of 2x, divide both sides by 2. You get
Yes, sir.
cos 2x plus sin 2x divided by 4. This is your I1,
Yes,
right?
sir.
Now
Yes,
put
sir.
it back in the integral. Hence, what is I? What was I here in the last one?
Sir,
I was
e2x
half.
cos.
I was this half e to the power of 2x
Yes,
by
sir.
2 plus I1.
Yes, sir.
Half e to the
E
power
to
of
the power
2x by 2
x
plus I1,
plus 5 only.
right? Let me check again if I am written correctly.
Sir, minus
Yes,
I1 also plus 1
plus
only.
I1.
Yes, sir.
Okay.
Yes, sir.
So now you just
Yes,
put the
sir.
values and it's done. Half e to the power of 2x by 2 plus e to the power of 2x cos 2x plus sin 2x will divide by 4, and you can add a constant of integration here. Okay. So now what you can
Yes,
do,
sir.
you can express it in if you want to express it in a better form, what you can do is you can take 1/4 common. You can write this as twice um, 1/4. So this is 1/4 e to the power of 2x. If you take out 1/4, so you simply get, in fact, if you take out half, yes, if you take out 1/4, if you take out 1/4, you get e to the power of 2x, right? Plus, and this is 8 uh, times e to the power of 2x, or you can take e to the power of 2x common throughout, e to the power of 2x, 1 plus cos 2x plus sin 2x. Okay,
Yes, sir.
whole divided by 2.
Yes, sir.
You can express it in this way also. Okay, so that's it. um, I think
Sir,
that is not entirely accurate. Let me just correct this. While taking the LCM, uh, things change a little. So this is
sir,
half here. Yes, what?
sir, I want to ask about the project. I have some confusions. That's why.
What? What do you want to ask?
Sir, in the first project, only we have to do the increasing and decreasing which the sums which we have gave, or we have to do maximum or minimum also.
Maximum, minima also.
Sir, the maximum minimum, the theory part which we have given that one, or whole
I
whole.
told you which ones to do, the theory part and the sums that you have to sort out. I told you that time only how to do.
Sir,
The
I
theory
for
part you have to write, and the sums part also. I told you what kind of distribution you should have between you and Amir. I told you
yes,
at
sir,
that time.
I have done totally the different. The 7 pages we have done, said to do that I
Hmm.
have done separately. That I
Hmm.
have done with the different books. I have combined and
Hmm.
some taken some question from the nets also
Hmm.
from that chapter. Sir, I am
Uh,
asking about the maximum and minimum.
yes, you
We
have to
will
do
do
that.
about the.
Yes,
Okay, sir.
increasing decreasing function is only the introduction to the project. The main project is
Okay,
on
sir.
maxima and minima. Increasing decreasing function is actually a introduction. It is a part of your class 11 syllabus.
Yes, sir.
Okay, so this is what how
Then
you
we
can
will
do.
do.
Okay, yes, tell me fast.
Sir, then we will do maxima or minima, no?
Yes, maxima and minima also.
After that, we will conclude, no?
Ah, yes, after that you can conclude.
Sir, in the linear programming problem that
Hmm.
project, I have done the introduction and we will do only the sums.
No, you will define everything. You will define what you mean by decision variable. You will define what you mean by constraints. Okay, and you will define. You will write the theory. Understood?
Okay, sir, the theory part
Okay,
you have
sir.
done.
Let me just give you hints on this one. Suppose if you are given this kind of an integral, e to the power of 2x sine x cos x dx, then how will you do this problem? See, sine x cos x can be converted to 2 sine x cos x, right? In this manner.
Yes, sir.
In this manner.
Yes, sir.
Now this can be written as half integral e to the power of 2x sine 2x multiple angle formula dx. Now we proceed exactly as we have proceeded above, right? So this was just the hints. You can
Yes.
do it on your own. Okay,
Okay, sir.
hints for this problem. And similarly, we can do this problem also. E to the power of minus x sine x dx. This also problem you can do is in a similar manner. So what the if the power of e is negative, it can be done exactly in a similar manner. Take this as your first function, take this as your second function. The integral will come as a recurring integral. Understood?
Yes, sir.
Okay. So the next problem that I wish to take up is I don't think I'll be able to finish. Uh, Integral 1 by x cube sine log x sine log x. Okay, dx.
Okay, sir.
Yes.
How to do this kind of a problem? See, in this problem, first you substitute t is equal to log x. Okay, so that means
Okay,
what you
sir.
get as dt dx? Dt dx you
Mm,
get 1 by x.
yes, sir.
That means you get dt is equal to dx by x. Okay.
Yes,
And
sir.
also, if you put t is equal to log x, then what does x become? X is equal to e to the power of t, right? Am I
Yes,
right
sir.
or not? So now what you
Yes, sir.
can
Yes,
Yes,
do
sir.
sir.
here is you can break this up as 1 by x square sine log x dx by x. Okay. And then what
Okay,
happens?
sir.
Dx by x becomes what? Dx by x becomes, this part becomes dt, right? So this becomes integral,
Okay,
and
sir.
instead of x you write e to the power of t
Then 1 by square. Oh,
square, and sine
yes, sir.
t you have taken log x. This becomes dt, right? So this becomes integral
Yes, sir.
1 by e to the power of 2t sine t dt. So this becomes integral e to the power of minus 2t sine t dt. Now you can do this on your own.
Yes, sir.
This will come as a recurring integral once again, right? So
Yes.
all, remember, note, all integrals of the form integral e to the power of ax cos bx, okay, dx, and integral e to the power of ax sin bx dx are recurring integrals. Remember, okay,
Okay, sir.
most of the integrals can be brought to these two forms, okay, and then you can do it by recurring integrals. Clear?
Okay,
Okay,
sir.
sir.
So this is, I stop here for